We'll see how that goes. All right, so my name is Gunnar, and I'll be giving a presentation on schema design and performance tuning with a little bonus of hardware sizing at the end. So basically, we're going to go through and sort of describe the InfluxDB data model. Then we're going to go and talk about how to design a schema in InfluxDB, and then we'll go over some best practices on applying a schema to an example, and then we'll get into like the nitty-gritty about like how to think about InfluxDB's performance and some of the ways that I've learned InfluxDB performs as a support engineer. And then finally, we'll discuss like how to think about hardware requirements and sizing if you're starting a new InfluxDB project. And first of all, since I know we've had 2 presentations already on InfluxDB, and a lot of you seemed like you were familiar with InfluxDB and had been to either meetups or viewed webinars or played around with InfluxDB, how many people sort of like know about the general operation of InfluxDB? Okay. Would anyone be mind if we just skip over like the intro stuff of how generally InfluxDB organizes tags and fields? Okay, great. So I'm going to skip that. Basically, in short, you've got tags in InfluxDB. That's a major feature, which are indexed, makes it easy to query individual series, series being time series, so a set of timestamps with a value, and you can have multiple fields in each series. It's organized in column or store, so it's really quick to pull up a whole set of series. There's also the concept of a retention policy and measurements, and if you've seen any of the webinars, you've probably seen Michael go through this a ton of times. So going on to general schema design. So I'm going to do some quick, there's going to be some like what to do and what not to do, and it's mostly going to focus on what not to do. So basically, when you're designing your InfluxDB schema, well, we see a lot of people coming from like Graphite and other time series databases, but mostly this happens in Graphite. You're coming with a concept of what a measurement name should be, and in Graphite, obviously, you've got these sort of like separated with a identifier, so usually a period or some other spacer. And in InfluxDB, that's not how you want to use the database, because basically to use the full functionality of tags, you need to separate them out into tags. And while you can query by a regex on the measurement name, it's going to be just slow, and you're not using the database the way it was designed to be used. So that's something to not do. And if you're doing that now, you probably realize that it works, but it's painful, especially when you're using, for instance, other tools like Grafana that expect you to use the InfluxDB sort of schema of tags when you're using their query constructor. So again, what if my plugin sends data to InfluxDB like that? There are a couple things you can do. In that case, you can use InfluxDB's built-in input to parse that. We've got several inputs, mostly Graphite, collectd, and OpenTSDB, and they'll parse those points. You can also use Telegraph, which takes a number of different formats. It also has its own plugins for like service-specific plugins. And then Telegraph will output line protocol with tags and everything like that. So I would recommend using Telegraph over InfluxDB's built-in input. But if you don't want that extra layer of Telegraph running in front of your InfluxDB, then definitely send it through one of these parsers so you can get tags out of your measurement names. The other thing to keep in mind is you don't want to overload tags. So if you're parsing graphite measurement names or graphite measurements into InfluxDB measurements and tags. You also don't want to have all of your tags having these sort of segmented values. So generally, tags should be discrete tag name and tag value, and nothing sort of tacked on the side. So that much, that just makes it easier to query, and as we'll see later, having that extraneous information on the tag values offers you nothing except, slightly more memory overhead. So don't use tags with high variability, and this is a really important one, and something that I don't know if you're at all familiar with InfluxDB at a large scale. You probably run into already, and that means basically tags are stored in in-memory index. So if you're storing basically like a tag ID or like an ID and a tag, and you're storing, every point has a different ID, or in some cases I've seen like people storing timestamps in the ID in a tag, that's going to end up bleeding over time to a significant number of tags. Now that's not always a bad thing, right? A lot of the point of tags is that it makes it easy to query by this, query this stuff fast. But it does come at a cost of memory usage, and so generally, cardinality might not matter that much for your use case, depending on how big your box is and what your use case is. And if you have less than 100,000 tags, or like a tag, tags with less than 100,000 individual values, you probably don't need to worry about it that much. Once you get higher up into like the hundreds of thousands and millions, and or if you're working with smaller hardware, then you might want to consider different options. And this sort of gets into several things where you can decide whether you actually need that tag or not. And in all cases, if you don't need to keep a high cardinality tag as a tag, don't do it. Just move it to a field. Otherwise, you can do some other sort of non-traditional architectures where you can shard across different instances, like basically namespace your tag, your high cardinality tags across different InfluxDB instances, and other things like that. Or if this is core to your requirement, you have like 10 million tags, maybe are you storing enough information per each tag that it makes sense to even use a time series database, and like, maybe you just need a key value store or something else. So the other thing is don't use a huge number of independent tags, and this sort of goes along with the like don't use a UUID or something like that. Basically, the way InfluxDB stores the underlying data, or basically what the way the tag set points to the underlying data, is that each series is identified by the measurement name plus the unique combination of each tag value and its each tag key and its tag value. So if you've got a bunch of different keys and they're all sort of pointing to different data, and it's not in those underlying tags, tag values are sort of every point has a different combination of those. That can also explode the cardinality of your database and increase the amount of memory in store. And let me know if this is going beyond what you guys know.
Okay, I'm gonna be the dumb one.
That's fine.
You were a little abstract in what you just said.
Mm-hmm.
And I'm gonna admit to not. I mean, I get kind of what you said, but could you try to rephrase it a little bit for the stupid amongst us and me?
Yeah, sure. Was there a particular slide that you had?
Well, you were talking about a lot of different tags and how they combine to make cardinality, and I guess, is it the concatenation of a tag that
Yeah. So basically, in InfluxDB, uh, every underlying time series, which is just a set of points, right, with a value per timestamp. Every one of those time series is identified by what's called a series key. And the series key is literally the concatenated string of the measurement name plus basically the string of the tag value and, sorry, the tag key and a tag value. And that's for each tag key. And there can only be, sorry, so that's for each tag key. So each tag key and value is appended onto that measurement name, and that itself is considered what's the series key. And the way the in-memory map works is right now it's sort of naive. The index implementation is sort of naive, and it just basically uses Go's built-in map underneath. But it basically, when you're querying for tags, there's just a map of a map, and it holds the tag, all the tag keys and all the tag values. And when you do something like, I want the the host that equals host 3 or something like that. Basically, what it does under the hood is it looks up in that Go map for the map of the host values, and then it looks in that, and then that underlying map then points directly to a series key, and then it pulls out all those series keys, and then goes to the database, goes to disk, and pulls all that out to actually return to the query. Sorry, that was a little bit in depth.
So there's not, when does it become a problem to have multiple fields, I guess, if you put things into fields instead?
So fields are stored.
It has to be numeric, right? Is that in the field versus tags?
Yeah, so fields are on disk. And the important thing to think about with fields versus tags is that tags are all stored in memory because we keep them on hand for easy access to, they're basically a pointer to the data on disk, which are the time series. And so the fields themselves are also stored on a disk, but the field map is also stored in memory too. So if you have like literally a lot of field keys, that might be a problem. And as of the recent versions, I think like 1.0 beta 1, I think they lifted the limit of like 256 field keys. So now you can have unlimited field keys. But the underlying data itself is all stored on disk. So
let's say I want to have two different tags because I want two different index views into something. And like maybe I want an index view that gives me the region that these things are in.
Mm-hmm.
And that'll organize the data one way, but maybe I also want another tag on there that aggregates by hardware type. Then I've got a bunch of different kinds of hardware type.
Yep.
So the combination of those two things is going to give me probably more of a unique identity. But looking at it either one way or the other, they're going to aggregate different ways. Is that
Yep.
what you were trying to talk about, and how would that affect performance?
This is mostly, so that when we're talking about cardinality, that's mostly about how much memory you're using. So in terms of like the actual query performance, we'll get to this later, but basically querying by tags is very fast. Yeah, it's all in memory. So generally, it's when you're thinking about this, you're thinking about what kind of data do I want to keep in memory, what kind of data do I want to push to disk. So, and the disk access is cheap when you're pulling a series because it's all in the same spot. It's all contiguous. So, all right. Other things you want to keep in mind: don't use the same name for a field and a tag. This is more just like common sense. Like, it's really hard to differentiate in the query language, and up until I think 0.13, there actually wasn't a way to specifically call out a tag that had the same name as a field. There's some new syntax in 0.13 where you can actually select the tag or the field value in the query language. So that's just something to keep in mind. It also will reduce confusion for anyone else who's coming by later and has no idea what's happening in the database. The other thing you want to do is don't use too few tags. So again, this is basically if you're querying by something and you want it to show up fast, keep it as a tag if you can. And it makes it really easy to seek that data. And also that goes with a particular note is the group by. So if you were trying to pull a bunch of different time series at once and apply a function to that, the group by only takes tag values. So if you want to pull out, say like the CPU usage, and you want to, I don't know, find the max grouped by all the different hosts. So like basically find the max value for all the hosts. You need host as a tag and not as a field, because otherwise you cannot group on it. And that's more, eventually maybe it will allow grouping by field, but probably not, just because that's so inefficient, because it basically has to go to disk and filter through everything. The other good thing to note is,
Just a quick question on that. So I'm trying to remember where in the things have changed in the different versions. But you can still group by time, right?
Yes, you can still group by time.
And time is not a tag or a field. It's like a special.
Yeah, so time's also basically an index because it's a time series database. So all time in the database is indexed, and it's really easy to seek. And that goes with that, basically the series on disk, when you pull it out, it's basically really easy to seek to a specific time. There's like a lot of optimizations that go into that kind of thing. But yeah, seeking to specific times is very fast. So don't write data with the wrong precision. An important thing to note about InfluxDB is you can write data at different precisions, and it'll store it differently on the underlying disk. So if you have data that's coming in at 1 second apart, you don't actually need to store at a nanosecond precision. And if you basically, there's a URL request parameter called precision, and if you set that to the actual precision that you need, when you write to the database, it'll store that at that precision. And so you'll get some benefit of basically a smaller size on disk, and in some small way a faster query response because there's less data to pull and go through. And that's not something you really have to worry about unless you're writing a ton of data. So
if you don't set the precision and you write at a higher precision, will it record?
It will record at nanosecond.
So you're intending once.
Oh, so it doesn't record anything between it, but the algorithm that is used to basically compress the data.
So it's going to update the one for the same second.
Yeah.
Okay. If you're on 1 second precision, it's just going to overwrite it twice. You're going to have the overhead cleaning it up. Okay.
Basically. Yeah, and like I said, it's not on here. Oh yes. Okay. Yeah. So at the bottom it says, make sure if you're using second precision that you don't have multiple points coming in for the same series in that second, because yeah, it'll get overwritten. So.
Yeah, I was curious what the downside was, whether there's too many samples or whether it's a cleanup operation.
What are your choices on precision?
You get nanoseconds is the lowest, and then, or I guess highest precision, and then you've got microseconds, milliseconds, seconds, and I think that's it. I don't think you can go higher than that.
So you go to millis, but not centiseconds.
Yes, I think so. I don't know. I don't remember off the top of my head. It's in the documentation. So most people record at seconds or nanoseconds or milliseconds. So but yeah, it's in the documentation if you want to look up the actual values that you can select.
How much is it documented how much space you save on each entry?
I don't think we have like the actual numbers documented anywhere. We could probably get that though. But basically, if you're collecting, if you think about it, each point, if you think of the way it's stored on disk, it's basically a columnar store. So you've got columns up top, and each row is a timestamp. So every point you send in has, a spot on disk that it could end up, depending on the, how much data you have underneath and how many points you're actually sending in, could end up to significant, I don't know.
Yeah, no, it just seems to me like the most, that you're not gonna, well, maybe you've got bit arrays that you're doing, but that just seems expensive, and that you'd at least do things on byte boundaries, so that would have an implication of, however many, whatever that translates to in binary time, which I can't do in my head. You'd go from like nanoseconds to maybe hundredths of a second by taking those 8 bits off.
Yeah.
I don't know what it is.
Yeah, and
Whereas you're not gonna, are you storing bit fields?
it's basically it uses the Gorilla algorithm underneath, which is, it's this algorithm Facebook had. That the paper's actually pretty interesting, but yeah, it's like bit manipulation and
Okay, so it might just be a bit.
yeah. But basically, if you store a higher precision, and when you only need a lower precision, InfluxDB stores the data on disk, assuming that at any time you could send in a higher precision point that's interstitial to the other points that you have. And so
It's going to lay out the disk space.
Yeah.
For all the intermediate points.
Exactly. So, which again is why if you send in 2 points in the same second, and you have it set to a lower precision, that it'll overwrite it because it literally hasn't, has already, has that space set away. Yeah. So what's the best schema? Overall general tips to keep in mind when laying out a new schema is basically always start with the questions of what you want from the data. It's great to collect everything, but at the end of the day, when you're talking operationally, you want to know, what questions you're trying to answer. And this is especially useful if you're doing some, custom client stats collection. So a lot of like the Telegraph plugins, for instance, sort of have pre-canned stuff that it sends in. In that case, the schema is like pretty much set out for you. But if you're designing something, application performance metrics or something like that, and it's something specific to your use case, or you're doing, some kind of, IoT thing, and collecting some kind of sensor data that's specific to your field, then you'll want to start out with the questions that you want to answer. Again, the things to keep in mind when you sort of think about your schema is that group by can only take tags, and functions will only take fields. So this is a little bit of counterintuitive thing too, is that you can't store basically like numeric values in tags, because you won't really be able to use them for anything because you can't apply functions to it. And really, you should only be applying functions to the underlying time series values as well. And also, keep in mind that there is a Boolean field too, and that's super cheap, obviously. So a lot of people write in like basically ones or zeros, or they use like a little literal string of true or false. There's a Boolean value in the line protocol, so you can use that. So we're going to do a quick design exercise, and I'm going to sort of fly through this because I got a lot of other performance stuff later. But basically, if you're trying to design a schema from scratch, let's say we've got a new air quality startup, or we're a government organization, or set up air monitoring, and a new air monitoring system. We've got 10,000 sensors we want to distribute around the country in a bunch of different cities, and we've got multiple sensors in each city, and each sensor emits data every 10 seconds. And we're, basically the data that we can collect from each sensor, when it emits that data, this is all the data. So we get like a lead reading, we get a parts per million reading on CO2, we get sulfur dioxide reading, get a bunch of different values, including like the latitude and longitude of the sensor itself. So what we want to start with, for instance, is in this case, the questions that we want to answer are pretty simple. But basically, we want like, median lead reading per day. We want like the average carbon dioxide parts per million per day. We want, we want to know the max smog value for the day. This can help us organize our data. So some different options we have for organizing this out is we could use like the graphite, like let's pretend like it's outputting in graphite format. We just use really long measurement names with a bunch of fields. Probably not a good idea because of the earlier recommendation that we should be using tags to split this up. You could do this, and you could use regexes on the measurement name to pull out the measurements that you want. But again, it's not the way that InfluxDB is set up for querying, and it'll be slower than you would otherwise want. So, and not quite as easy to query if you're writing a ton of regexes. The option 2 is to put everything in fields. So maybe you're thinking that you just want to, you're not, maybe you don't really care about the city or something like that, or maybe you're just getting a ton of points and, you want to keep latitude and longitude as a field. That's also not a great query, a great schema, because if you think about like latitude and longitude, for instance, that's almost never going to change for a sensor that's doing air measurement. Unless you've got it on the back of a truck or something, you're going to want that as a tag. But again,
But it's going to have a huge amount of cardinality, right?
it's not going to have a huge amount of cardinality if it's in a single spot.
Well, but if you have, it's going to have the cardinality times the number of sensors, right? So lat long times the number of sensors.
Yeah. But it's not going to be as bad as if it was having a different latitude and longitude on every point, right? So every sensor, so it'll add some cardinality, but it'll only add as many as there are sensors, which if we have 10,000 sensors is only, again, 10,000 tags. And in the scheme of things, that's not actually that many.
There's not a way to do geographic functions yet, right? So
Yeah, we don't actually have geographic types. It's definitely in the future. Yeah. But we don't have geographic types at the moment. So we also have option 3, which is to do a single measurement with 5 tags. And actually, I think I lied on the latitude and longitude. So I'm just, avoid my advice about the latitude and longitude.
Yeah,
it should be a
I
field.
thought we were doing fields, but I still don't quite understand how it gets cut properly.
Yeah, so
But
this is a place where it's sort of ambiguous, and again, goes to the questions that you want to answer. In this case, since we already have the city and the zip code, to be honest, latitude and longitude is something that I might store in some other service. Like the actual, like if we have like an SQL database or something with more information on the sensors, I'd probably just store the latitude and longitude there. Assuming it's not.
key to like look up.
Yeah, use a key and something.
But isn't that going to give some enormous query with a zillion?
Yeah, so when you query it under the hood, it's actually not going to pull that data. It's not going to slow it down too much because it can pull as separate. Basically, it's stored as a separate series underneath in the columnar store. So it's not actually going to slow it down pulling it from disk because the latitude and longitude is on disk. But there's also no point in having it on disk in the first place, I guess.
So
Yeah.
you throw the latitude longitude out, you put it in your relational store, and you have a key from the relational store to your time series store, but still going to pull the query into the time series store is going to be enormous. If you have, say you have 1 million lat longs.
Well, yeah, you could just not select on the lat long, so.
With 500,000.
Yeah.
You know,
Yeah, it would certainly
IDs
increase your
being
rights
fed
and
into
stuff like that.
Influx seems like that not very good.
Well,
Yeah.
in the case of fixed point sensors, you're gonna have a fixed number of lat longs, and I mean, the way I was thinking of it, you might actually want to look at, say, something, well, you're not taking temperature here, but temperature at a latitude, you know, that
Yeah.
might be an interesting way to query, in which case you would want an index on that.
Yeah, I think what ultimately for the lat long is that we don't have, geodata point, a geodata type, and so you can't do like a bounding box or anything like that to query that
That's
kind of
really the
stuff.
problem, is
Yeah.
not- is
Maybe one day we'll have that.
Oh, actually,
So,
it's in the roadmap.
yeah, it's on the roadmap. There we go. So if we look at our full schema, the example line protocol is here, and then our queries would basically be a fairly simple, standard sort of almost pretty much standard SQL to pull this data. So onto the fun stuff. And this is going to be a little bit hand wavy, so feel free to interrupt me if you want like more explanation on some of this. But this is just sort of like general tips that I've learned over the years, over the year, I guess. Basically, generally, if you're using InfluxDB 0.10.0 and later, it's CPU heavy. So we do a lot of encoding under the hood, and so all that encoding requires a lot of CPU. So you'll find that for the most part, you're going to want to have a large CPU. And depending on your, as mentioned earlier, the cardinality and stuff like that, and how many tags and stuff you have, you might want significantly more CPU compared to the memory and stuff like that. It's also optimized for SSDs. So basically the short answer is don't use InfluxDB on a spinning disk if you can help it. That's again something that we plan to optimize, like improve in the future as people start to get large, like terabyte size data sets and stuff like that. But I guess as the price of SSDs are coming down, it's not quite as a requirement as it used to be. And then the other thing to keep in mind is memory usage is at the base level, memory usage is defined by the number of unique series in the data set. And that goes back to what I was mentioning earlier about the tags, and that's going to be like sort of the base memory usage is basically the number of tags you have. The next contributor to memory usage is going to be queries and the intensity of your queries. So the rule of thumb is that group by queries use more memory than regular queries. So if you're doing a lot of group by queries, which Grafana will do by default, it will use more memory. And generally, once you start to get above, like, basically, if you're returning more than 10,000 points from a group by query, you're going to start to see like significant memory usage because basically InfluxDB will allocate all those buckets when it gets that query and starts putting those, filling out those buckets with the actual values. And then the final contributor to memory usage is write load, and this is something that is also up for improvement. Is that HTTP load does a number on InfluxDB memory usage because it'll f-sync on every request. So I don't know has anyone's played around with like write throughput on InfluxDB, but you'll find that you always want to batch, and this will be later, but you'll always want to batch as many points as you can per request and reduce the overall number of requests, especially if you're using HTTP. So it's not a problem if you're using UDP. Obviously, there's other trade-offs there. You could drop points. And there's also a small window when you're using UDP where it'll f-sync only once per second or once it gets 5,000 points, whichever is first. And that's configurable in the UDP configuration. And other tips for write format. InfluxDB has this line protocol. It's pretty good, and it's optimized to use that. So if you can, recommend using line protocol where you can.
So what does Telegraph use under the covers?
Telegraph is basically a translator between different protocols, if you can think of it that way. And under the hood, it uses line protocol because it was built for InfluxDB. So everything in Telegraph is pretty much optimized for the line protocol format. But you can also, it has.
So in the out-of-the-box configuration, since we're just starting to use Telegraph, we drop click the input Telegraph in, but haven't looked at what it's doing under the covers. We can suffer data loss, not tremendous amounts, but
Yeah.
We can drop 10 seconds of data and not really care about it. And we're willing to take that, reliability trade-off for the performance gain. So is it configured that way out of the box, or what should I do to change that?
Yeah, so the way Telegraph works is you've got basically plugins, and you can have input plugins, and you can have output plugins. There are some other plugin types, but basically those are the two main ones. And the input plugins will be, for instance, like a graphite input, which will accept graphite format and collect the input. And then there are a number of outputs. So you can actually write from Telegraph to a number of different outputs like Elasticsearch or Prometheus. But the InfluxDB output is, I guess, the one that's like most optimized.
And that's the one we're using.
Yeah.
The only reason we're using Telegraph is because it interfaces with Influx.
Yeah, and the InfluxDB output can also do different protocols as well. So you can, pretty sure you don't have to do just HTTP.
So my question is, what, if anything, do I have to do to the out-of-the-box Telegraph stuff?
If you use it 1,000 out of the box, I believe it batches at 1,000
Oh,
and
does
sends
it
them
bat-
every second.
Okay.
Yeah.
It's right in the line.
Yeah, yeah.
Then it
says
sounds
it
like,
a spit
then it's not,
out.
I wasn't the one who
Yeah.
put that in, so I haven't read all that. So it sounds like nothing. I don't have to do anything.
Yeah, for the most part, Telegraph out of the box will work great. So
Okay.
this is more about if you're building your own client or writing something new directly into your program or something like that.
Yeah, I actually have a question about that. If you're writing something in your program, is it better to go through Telegraph to Influx or go straight at Influx? Like I wrote an app and I wanted to admit metrics.
Yeah,
And I have Telegraph, maybe grabbing CPU.
that's a good question.
Yeah, so let me take a stab.
Okay, yes.
Depends on what you are trying to pull. So if you're trying to query a API endpoint and get metrics out of that, Telegraph has an executor plugin which you can pull, right? Or if you want to execute a script, if you are actually doing custom instrumentation in terms of annotating your code and spitting metrics
like a
to
gauge or
so if you are spitting to a log, Telegraph actually has a log parser plugin
Right.
for that. But if you really want to just hook in and emit metrics from methods and all, then a preferable way would be to use the API.
That seems like it'd be a little dangerous anyway, because you don't necessarily have a finite control of when the messages are being written, so you might have one message overriding another message. So like the way we do it is we write out a status endpoint for a particular app. It just gives the metrics we're interested on the app, and then we just ingest it with Telegraph, the JSON, HTTP JSON, and then shove it into Telegraph. or
So
shove it
you
into
consume it
endpoint.
as a log, basically?
No, it's not a log.
It's a poll,
It's
that's
a
it.
poll against against a
Yeah, you can consume
HTTP endpoint that serves up a JSON. essentially.
Okay.
And
Yeah.
the cool thing
So-
about
so
that is it's
Telegram
totally
calls
generic.
your
So
app.
like you can just take your app, spit out this JSON with a status message, and it just shoves it into Telegraph, and like you didn't write any code other than the minimal thing that gives you
The
the status.
HTTP JSON piece.
The status,
Yeah.
which is
even like if you
version count, uptime, how many messages it dealt with, whatever the problem is of the day.
Yeah, I would say a general rule of thumb is like basically how multi-tenant is your database, like is your InfluxDB database. Like so if your client is the only thing running to it and you've only got like 3 or 4 clients running, just stick with InfluxDB if you can output directly to line protocol. Otherwise, if this is going to be like part of like an sending stats to an InfluxDB where you're also expecting to have like, tens of other services and, everything sending in different, using different methods to send the data in, I would use Telegraph. Because Telegraph will be a little bit more configurable in terms of if you want to support multiple things.
So as an alternate implementation, one of the measurements that we take, we actually, there's a Java language binding for writing stuff that we used in, we were taking JVM heap stuff, which is pretty complicated. And so we used the Java language binding to sort out that information. It wrote directly to Influx.
Take a look at the Jolokia plugin.
We use the Jolokia plugin.
Oh.
This is way more complicated than anything we would do in JMX. There's a JMap thing that will dump everything in the heap, and we need to record that on a timing. And there's like a boatload of data that comes out of there, and we have to coordinate when the heap measurements are taken. So it's just the last step of okay, let's sort this in Influx.
Yeah.
I mean, we might have been able to do it that way as well. The way we did it was easy.
Yep. Good.
Will there be a binary protocol at any point?
It's in the works, or in the.
Sort of annoying
I-
to have binary data and convert it.
It's on the roadmap.
To be shipped.
Protocol.
Yeah.
Yeah, today we do what? MQTT, UDP, TCP, and I think Protograph is another one, right?
Yeah. The thing with the binary protocol is just that it requires, hooking everything up and making sure all the clients speak it, and
Well,
but yeah.
I mean an endpoint, right?
yeah, of course.
If you're writing a custom app and you have control over what you're emitting, then we have relatively high data volumes, and they're already in binary, and it's stupid that it gets rendered to ASCII
Yeah,
so it can be reprocessed.
Yeah, it's definitely. I mean,
Dependency that I want to pay for.
yeah, it's definitely on the roadmap. Yeah, I guess that's all I can really give you for now.
Convert it to its tag and data form when it got to Influx stuff.
Hence the binary protocol.
Right, yeah, in
Yeah.
particular, if you've got a, bespoke application from a client standpoint, and you can have reasonable guarantees or suffer the pain that you don't, of providing valid data to avoid the overhead of the parsing and validation side of Influx. We would find value in that.
For sure. Yeah. So it's.
There are any number of well-known schema tools for message protocols.
Yeah, and InfluxDB actually uses protobufs under the hood, so adding a protobuf, wouldn't be too hard. I think it's just more of it's on the roadmap, and there are other features that we've been prioritizing over it. Mostly because the line protocol has been basically good enough up until this point. So, but I think we're seeing people use it at the scale and the intensity that it makes sense to have a true binary protocol eventually.
Just to roll back, I think the gentleman a couple rows in front made a comment before about Telegraph or whatever you're using, the HTTP versus UDP protocol. If you are going to switch to UDP and it's a good idea to understand your traffic, especially if you have very large amounts of data sources, the frequency of the data endpoints, and also your network characteristics, and tune the MTU of the packets for it, because that can make actually a pretty significant difference. I think the default is assuming pretty much internet level traffic, and of course granularity is not 512, but on a high-speed internal network, you can squeeze a little more juice out of it.
Yeah. The UDP protocols. If you switch to UDP, obviously.
Thankfully, haven't had to think about MTU size for a while, but it is good advice. I've used that trick before.
Yeah, we're testing with a few data points, so
Yeah.
it's actually become a thing.
Cool. So going on to query tips. Basically, query tips are, and Grafana used to be a huge offender of this, is don't send queries if they don't return. And it's not due to like a connection error or something. Because usually if you send a query and it's taking a while to return, it's because it was a very wide query and it's pulling a lot of data and it's going to return a ton of data to you. And it's a little bit better now because as of 0.13 we have a query manager that'll automatically kill queries once there's a disconnection and under some other circumstances as well that are configurable. But basically, if it's, if a query is not returning in 5 seconds and you hit refresh, it's not going to also, magically return unless you or something like that. So
Probably will get slower.
yeah, exactly. So as mentioned, there's also a query manager now. I'd recommend checking it out, and if you want to build in some client application code or something like that to use it, that'd be fun. There's basically some InfluxQL that you can use to kill long-running queries and stuff like that. So also, if you're just running regular queries, one thing to keep in mind is just try to tightly scope queries as much as possible. So that means the time range should be explicit and is just as much as you need, and try and pull as few series as you possibly can. Because under the hood, if you're, for instance, doing like a select star on a measurement with 10,000 series, under the hood, it's basically merging the union of all those different series when it's sending back the results. So generally, if you're querying fewer series and more scoped query is better. And also, feel free, you should really, if there are things where you're setting queries over and over again, and querying basically the same calculated data. So if you're using a query with any kind of function and you find that you're sending it at a periodic time, basically like you've got a Grafana dashboard or something like that, and it's starting to slow down, use a continuous query, or even better, use capacitor. Better being it'll be probably more performant than setting the query in with the same function over and over again, just recalculating all that data.
Use capacitor instead of a continuous query?
I'll get to that in a couple slides. So yeah, I think we've gone through all these tag tips basically. Yeah, again, literally longer tags will use up more memory because it stores plain text in the index. So storage tips. So these are interesting. Basically, integer and floats are very small, particularly if you're doing like non-random values. So if you're doing like a sensor reading and like basically only going up and down a little bit, the compression that we use under the hood is really efficient, and it'll really basically store that really cheap. If you have random values, it'll compress poorly or not quite as well than if you have sort of contiguous values. And string values, the space that's required is basically how much it can compress those values. And then, yeah, I guess, so contiguous time series, contiguous time series themselves also compress better. So it could be used as another argument to try and keep like the number of series you have down as much as possible, in that basically, if you think of the time series as a set of points, right, the way that compression works is the longer that set of points is, the more compressed it can be. So if you've got a bunch of if you've got a bunch of series and you only have 10 points in each series, you're not going to get the compression benefits of if you have a series with 1 million points in it, the per point compression at least. So, and for timestamps, I think we already talked about this, but basically you're going to want to use the lowest precision you can that makes sense for your use case. So if you're sampling, on 10-second intervals, use second level precision. And also, periodic timestamps will compress better than irregular timestamps. So again, it's just like different encodings that it uses under the hood. So for continuous queries, use them as much as possible. They're basically built in, and it's usually best to avoid very complicated continuous queries, if only for the fact that if someone comes along later and is trying to figure out how this measurement is generated, that they can go through and figure out exactly how that query worked and the actual output. The other thing to this is that continuous queries definitely have limits on the scalability within the system right now. It's definitely on the roadmap that we're going to fix this, but basically the way it's currently implemented is not super optimal for running a large number of continuous queries. So once you get to a certain frequency of continuous queries, which will depend on what the queries are actually running, you could see them start to literally they'll like back up to the point where the one before it didn't finish before the next one's executed and stuff like that. Again, that's very dependent on what kind of continuous queries you're running and you know how much data each continuous query is going through and writing back in. But there's definitely like a very fine limit of once you get to a significant frequency of continuous queries. I'd say if you have more than I don't know, like 50 fairly intensive queries running on a large number of tags, that you should start to think about how much that's impacting your performance. And the rule of thumb is that if continuous queries start to be a performance problem, switch to capacitor. And capacitor will allow you to do, I don't know if everyone's here has checked that out, but basically capacitor is our basically computation engine on time series, and it'll allow you to do basically stream processing and a bunch of other fun stuff, and a little bit more intensive processing with a little bit more complicated functions and stuff like that on your data than what's available in InfluxQL itself. And that's also hooked in pretty tightly, like Telegraph, with the way InfluxDB works.
Yeah, and I think just to add there is, if you're looking at a clustered environment, it might be wiser to use capacitor because it's running as an independent process. So first, it does not eat into the CPU cycles of the database itself. It's running standalone, and you might at some point want to just do batch versus streaming. Certain data points you need in real time, other are longer term analytics. So you have the flexibility of switching those modes. Plus, if you are looking at functions like map reduce jobs, a lot more complicated built-in functions, you have those.
Certainly complicated stuff seems natural to pull out faster, but I'm a little surprised that like the simple roll-up stuff even would back it up.
Oh, I mean, so yeah, so you can get pretty far with continuous queries, and definitely don't think that you need to like go switch to capacitor. I would definitely recommend using continuous queries over capacitor for as much as you can. And then I just wanted to note that there is a limit to how much you can do with continuous queries themselves. And again, that's more about just the way they're implemented right now. They're not quite as tied directly into the underlying data store as much as they could be. So yeah, so that will be improving down the road. But basically, if you're doing a ton of different, like something super complicated with your continuous queries, it's probably better to just pull that out into capacitor.
Long change processes would definitely benefit from getting a dedicated
Yeah.
piece of hardware.
Yeah.
As opposed to the one that's shared with the data.
Yeah, I'll give you a classic example. The developer for capacitor just did a webinar around smoothing. So you can apply like different smoothing patterns. One is exponential smoothing called as Fort Winters. So you cannot do that in continuous.
Right, yeah, I mean, I would expect that.
Definitely use capacitor.
Other performance tips are retention policies. Use them. They work very well. They're very cheap. Some things to keep in mind about retention policies. There is a little bit of lag depending on basically the shard group duration between when that data sort of basically is older than the retention policy limit and when it actually is dropped from the database. So that's something to keep in mind in case like you're starting to acquire a bunch of data and you're starting to fill up your disk and you think, oh, well, I just want to like, reduce my retention policy. Yeah, so you'll find that you gotta wait for that. Basically, the way it stores underneath the data or under the hood is InfluxDB will store basically at time series as shard groups, and each shard group has a duration of like a day or an hour or a week, and that's configurable per retention policy, and that's sort of like the base underlying file that it stores it as, and it will only drop that file once all the data in that file has sort of gone past the expiration date of the retention policy itself. So, so for instance, if you have a month-long retention policy and you've got a shard group duration of a week, you might have data from up to 5 weeks old in there until that last little bit of data in that last shard eclipses that 1 month retention policy, or that 1 month sort of duration, and then that whole file will be deleted. But that's just something to keep in mind if you plan to get close on how much disk you have. Along with that point, you'll want to use longer shard group durations in general. That's the general rule of thumb, just because for a number of reasons, including obviously you'll have more data within that file, so the encoding will be slightly better, so slightly more disk space, and that really becomes evident when you, like, for instance, if you have a shard group duration of an hour and you've got a ton of series and you're only writing a few points per series, then you can really see some amplification on the encoding doesn't work great if you have fewer points in each actual shard file, and that's where you want to do longer shard group durations. So, and then so the other thing to keep in mind is databases, retention policies, and shards are very cheap to drop. It's basically deleting files on disk, but deleting measurements in series is not cheap. And I don't know if anyone's tried this before, but it's very expensive and not well optimized. So basically, if you can avoid it, don't delete shards and measurements.
Does it eventually recover the space?
It does.
Like
It does. Yeah, it doesn't like it. So InfluxDB in general is not designed for those kind of deletes. So so just if you can avoid it for your use case, definitely avoid it. So if not, it's not the end of the world. Like if you're just doing some cleanup, it's definitely you can do that. Just don't make it part of like your automated workflow to delete series and measurements. So some little bonus at the end, just general hardware recommendations. If you're starting a new project, in general, if you're starting a new project, the best way to determine your hardware is to do a test with your simulated production load. That'll give you the best results every time. Obviously, it's like pretty much how you're going to be running it. If that's not possible, try to do your best to approximate your anticipated production load with our stress tool, which is called InfluxStress. It ships with every package of InfluxDB. And it's pretty easy to set out a schema in that that will write whatever you think your LAN protocol is going to come in as. And if that's not possible, then at the very last, you can use these general recommendations to start with your initial box or something like that. So as I mentioned, depends on many factors, what kind of box you want. But in general, if you're considering like different load profiles, we're just going to say 25,000 writes, 200,000 writes for moderate load, and a high load of like greater than 200,000 writes per second, and then a probably infeasible load, and this is for a single instance, by the way, of 800,000 writes per second. So these are the hardware requirements for those, and I can flip back through these if anyone wants to go back and reference what the profiles were. But again, this is going to be really dependent on your use case. In particular, what format you're writing your data in, what protocol you're using, how many writes you want. Like a lot of people have, don't have very intensive write load, but they have a really intensive query load. Other people have the opposite, and it's going to change on how much you need of each resource for that. Again, testing is the best way to get an accurate number on this. So. And then in general for storage requirements, again, testing is the best way to go about this, but at the base level, floats and integer values are pretty cheap. So you can get almost 1 billion values at 3 gigs on disk. And then it's also easy to sort of like calculate the general amount of on-disk data you need to use, especially if you've just got like integers and floats. Strings are a little harder because the compression is a little bit more variable. But in general, if you're doing the telegraph default of a point every 10 seconds, so 6 points a minute, it's easy to say 60 minutes a day, or 60 minutes an hour, 24 hours in a day, 365 days a year. Gives us the 3 million points, which is about 12 megabits of disk. So extrapolate as much as you want from there. And that'll obviously change again on like basically the randomness of the data, how much it can compress for your individual use case. Again, using the stress test is the best way to get a good idea of that. So again, if you haven't heard, our clustering is now closed source. But if you are interested in clustering, generally clustering will get you a higher write throughput, will get you higher availability if a node goes down. Obviously, you can still respond to queries. And it'll get you additional data durability, so you'll have multiple copies on different nodes. And when you're sizing a cluster itself, it'll very much depend on your retention policy, which has a replication factor. The replication factor basically determines how many copies of each shard it'll keep on different nodes. And one thing clusters won't do right now is reduce the memory requirement. So if you're looking to use a cluster to let you write 10 million series, that's not going to be possible at the moment. So down the line, definitely, but not right now. Unless you want to spin up like a 50 node cluster, then you should certainly talk to us. But otherwise, it won't significantly reduce your memory per node. And there are some open source ways to get high availability, specifically using InfluxDB Relay or using setting your clients to write to 2 instances at once. And in those cases, you'd pretty much want to use the same sizing that you would use for a single node. So, yeah. Any questions?